All right, hey folks, welcome to the intro video for our new unit where we are going to start out by just reviewing square roots of perfect squares before we move down in here to finding square roots of things that are non-perfect squares. You should have already filled out this chart up here if you just want to briefly check your answers. And while you're just briefly scanning through, making sure you've got them all, I want to point out that 1 through 15 squared, chances are that you already had them memorized, and this school year you're working on knowing and memorizing that 16 times 16 is 256. Let's see, 17 times 17 is 289. 18 times 18 is 324. 19 times 19 is 361. And 20 times 20 is 400. So these right here highlighted are kind of the newer ones, I would say, this school year that you're focused on memorizing. I could ask with words, what's the square root of 196? Or I could use it with the symbol right here, the square root of 196. That was this one right here. So you could see the symbol, the square root symbol, or I could straight up ask the question. I want to remind you that the 196 is actually something called a perfect square. 4 here is a perfect square. 16 is a perfect square. 81 is a perfect square. So 81 is the perfect square and 9 is its square root. Down here on the number line, the square root of 324 is the 18, so y'all should have put the square root of 324 right here. We have 4 squared is 16, so that's going to go right here. Square root of 121 is 11, so y'all should have that right here. 2 squared is 4, so that should be here, and square root of 36 is 6, so we have that one here. 3 squared was 9, so y'all should have put that one there. And then last but not least, the square root of 1 is 1, and that would go right there. All right, so this was perfect squares. We talked about those at the beginning of the school year. And we also, at the beginning of the school year, talked about breaking numbers down into one of two main categories. They're either rational or irrational. Now, the rational numbers we further subcategorized into integer, whole, and natural. And so we already know that the square root of 121 is 11. We already know the square root of 36 is 6. So we already know how to handle rational perfect squares. The focus of today's video is going to be actually how to estimate where these numbers are. And we're going to estimate between two consecutive numbers where the number is. Okay. Now, to give you an example of what I mean by consecutive numbers, so if I said the number 10, the next consecutive number after that is 11. So consecutive basically means back to back, okay? Now we're just going to try to estimate the square root of 20 without needing a calculator. I don't know the square root of 20 and I don't know the square root of 85. That's what made them irrational at the beginning of the school year. And now I'm going to teach you guys how to actually estimate what that number is without needing a calculator. Now to do that, we just need to know the closest perfect squares around the number. So I want you to think back up here to this chart, and I want you to think about perfect squares. So for example, 25 is a perfect square, and 25 is actually the closest perfect square to 20 that's bigger than 20. And 16 is a perfect square that is less than 20. So if we were to take the square root of 16, we know that that would be a 4. And we know if we were taking the square root of 25, that that's a 5. So since this number is somewhere in between them, this has to be between the numbers 4, and then this is me writing the word and. That's 4 and 5. So this is 4 point something. The square root of 20 is 4 point something. Okay, the square root of 20 is 4 point something. Now if we look, 20 is 4 away from this perfect square, and it's 5 away from this perfect square. So it's a little bit closer to this perfect square. So it's a little bit closer to 4 than it is 5. So not quite at the halfway, but slightly. I mean, it's going to look a lot like the halfway mark. And right there, somewhere between 4 and 5 would be the square root of 20. And that's the goal of today's video, is to figure out between which two consecutive integers, so in this case 4 and 5, we can find the square root of something that's not a perfect square. Now, to double check behind myself, I'm just going to get the calculator. Remember, I'm trying to do this without the calculator, but to just kind of check to see where we're at. If I do the square root of 20, See how I said it was going to be closer to 4 than it is to 5, but not by much. So it's like barely right under 4.5. And that's kind of what I was saying. All right. Now let's do the next one. So for the square root of 85, so we got to think about the perfect squares that are around 85. Now the closest one that I can think of is 81, and I know that 81 is smaller than it, so I'm going to put 81 kind of on this side. And that's going to be 9 squared, and then 10 squared is 100. So this is going to be between the square root of 81 and the square root of 100. So it's between 9 and 10. Now, where is it between 9 and 10? We know it's going to be somewhere here between 9 and 10. Now, 85, see how 85 is much closer to 81 than it is 100? So this is going to be much closer to this. So the square root of 85 is going to be pretty close to 9. So I'm going to kind of estimate it kind of close to the 9. And I'll put the 85 up here. And to just kind of prove my point, like I said with a calculator, if we check, if I take the square root of that, see how it's 9.2? So see how if it's between 9 and 10, I could estimate that it's closer to the 9 because 85 is closer to 81 than it is to a 100. All right, now in blue, let's try the 211. Now the 200s, we're getting a little bit bigger, so you might need to look at your chart if you need to look at that. But I remember that 225, so 225 is near here. So 225 is a little bit bigger, and that's if we did 15 squared. So 15 is the one that's bigger. Let me do the 14 one. So that's going to be 196 right here. That's the one that's less than 211. So again, if I did the square root of 196, I know I'd be at 14. And if I did the square root of 225, I'd be at 15. So this has to be between 14 and 15. Now the question is, where in between 14 and 15 on the number line? Now with this one, if I'm considering 211, 211, it's, 14 spaces away from this one. And from this one, it's actually 15 spaces away. So it's pretty close to being in the middle. It's 15 spaces away here. It's only 14 spaces away here. So it's pretty close to being in the middle. So I'm just going to kind of estimate that pretty close at being in the middle right there. And we'll put a square root of 211 right there. And let's just use a calculator to kind of see if I estimated that one. If I did 211 and I do the square root of that, yeah, see, 14.5. It's like pretty much smack in the middle. And like I said, it's a little bit closer here. So if you want to like try to move it, like, I mean, again, it literally doesn't matter, but it's like pretty much in the middle. All right, and then last but not least here, we'll do the last one. Let's get orange out here. All right, so 2. Now 2 is really close to 1, so the square root of 1, and then 4, or square root of 4. Those are the perfect squares around it. So square root of 1 is 1, square root of 4 is 2, so this one's going to be between 1 and 2. In between 1 and 2. Now, where in between 1 and 2? So 2 is closer to 1 than it is to 4. So since it's closer to 1 than it is to 4, I'm going to put it closer to this square root than to that one. So if it's between 1 and 2, I'm just going to put it, a little closer to the 1 than it would be to the 2, and that's going to be square root of 2. And if I check 2 square root, yep, see how it's like, it's the 1.5 is like the halfway mark is kind of how I like to think of it. And that means it's closer to the 1 than it is the 2. So if the 0.5 is halfway, I kind of put it on the left of that to show it's a little bit less. So that's what we're doing here, folks. We are estimating the values of these square roots and kind of seeing between which two consecutive integers we can put that on a number line. All right, so now let's flip over. And we've got 1, 2, 3, 4 more now for practice. All right. Now, when I'm looking at the square root of 51, I think a lot of us are going to instantly remember 49, and that's a 7. So square root of 49 is 7. And then square root of 8 is 64. So it's between these perfect squares. 51 is between these perfect squares, which means the square root of it is going to be between 7 and 8. Now, if I'm looking at 51 and I want to kind of see, is it closer to 49 or is it closer to 64? I mean, 51 is only 2 away. It's only 2 away here. And here it's 13 away. So this answer is going to be much closer to the 7 than it is to the 8. So if it's between 7 and 8, I'm going to put it right here because it's supposed to be closer to the 7 than the 8, simply because 51 is closer to 49. All right, so I've got that one there in blue. All right, now the square root of 12. All right, let's think about this one. Perfect square is around 12. So 9 is a perfect square, and 16 is a perfect square, and 12 is in between those, which means its square root is going to be between 3 and 4. So if it's between 3 and 4, let's kind of determine where. Now 12 is 3 away here and 4 away here, so it's actually pretty close to being smack in the middle. So we'll put the square root of 12 kind of in the middle right there in red. So we've got the square root of 12 here. And in blue earlier we had the square root of 51. All right, now we're on the third one here for 305. Now, like I said, once you get into some of the bigger numbers, you really might need your chart to remember what the perfect squares are around it. If I look in the 300s, like here's 361, here's 324. So 324, let's go with that one. 324 is a little bit closer. So 324, we need that one. That's the bigger one here. And if that was 18, then 17 is going to be right here, the 289. And again, when we take the square root of both of these, that's a 17 and an 18. So we know that the square root of 305 between them has to be between 17 and 18. So it's going to be 17 point something. Now, when I look at 305, again, comparing it to 289, we can see here that it's 16 spaces away. And right here, it's only 13 spaces away. So it is actually a little bit closer to this end. It's a little bit closer, but it still feels kind of halfway, but a little bit closer to the 18. And so that was the square root of 305. And last but not least, we'll do this one here in purple. So 130. All right, so let's think about the perfect squares near 130. So 121 comes to mind. So 121 is less, and that's the 11. And then 144 is going to be above it. So if the square root of this is 11 and the square root of this is 12, then we know that this square root has to be between those, so it's between 11 and 12. Now, if it's between 11 and 12, that means it's 11 point something, so let's just figure out which one it's closer to. 30 is only 9 spaces away here, and it's 14 spaces away here, so it's going to be closer to this number, so it's going to be closer to the 11. And I'm going to put a 130, and that takes care of us kind of estimating on a number line where these values go. Now, without a number line, this part's going to go a little bit quicker. We just want to see without a number line just how to determine between which two consecutive integers the square root's going to lie. Okay? So on a number line, where between which two numbers would it lie, except we just don't actually have to plot it on the number line. So 11, let's see, we've got a 9 and I guess 16. So if it's closer to the 9 than it is to 16, it's going to be a 3 point something, but it's going to be between 3 and 4. Okay? Let me kind of move that 16 over here just a little bit. So it's between 3 and 4. And again, the reason I know that is because 11 is between the perfect squares 9 and 16. And so if this perfect square root is 3 and this is a 4, this has to be somewhere in between them. All right, so for 89, 81 comes to mind. We have an 81, and that's going to be 9 squared. So this must be between 9 and 10, because 89 is between 81 and 100. All right, for the next one, 28 is really close to 25. 25 is less than it, though. And that's going to be 5 squared. So this must be between 5 and 6, because 28 is between 25 and 36. Now we can see again 28 is closer to 25 than it is the 36. So it's going to be less than 5.5. It's going to be closer to the 5 than it is the 6. And now last but not least here we have, let's see, we've got 111. So 121 comes to mind, and that's bigger than it. If that's going to be 121 and that's 11, that's the bigger one, then this would be the 100. So that would be 10. So between 10 and 11. Okay, and that almost looks like it'd be, you know, kind of halfway in between. It's pretty close to halfway in between. So that'd be pretty close to a 10.5. All right, And now for this, instead of a number line and just determining what it's between, we're actually going to compare it to a decimal value and see if it would be bigger than or less than that proposed number over here. So first thing, let's just think about the number 340. It is bigger than 324, okay, and it is less than 361. So the square root of 324 is an 18, and the square root of 361 is a 19. So we know that this number is somewhere between 18 and 19. Now the question is, do we think it's closer to 18 or to 19? And now we just got to kind of compare, okay? So 340, if I'm comparing it to 324, I can see here that it's 16 spaces away. Here it's 21 spaces away. So this number is closer to 324. So when I'm talking about the square root of 340, it's going to be closer to 18 than it is to 19. Now, if I draw a line here to kind of think of the halfway point, 18.5, like I just said, 340, it's going to be closer to the 324. So the square root of 340 is going to be somewhere on this half. So see how it's going to be like a lower 18 point number? 18.9 is way bigger close to this. So 18.9 is bigger than whatever would be over here on this side. All right. Again, all I mentioned was that 340. If 340 is closer to 324, I know it's the answer is supposed the square root answer is going to be closer to 18. So it's going to be something like an 18.2 or an 18.3. All right. Now to verify and confirm, I don't want you guys using the calculator. See how it says no calculator? But because we're taking notes, I just want to prove my point that if I did the square root of 340, see how it's an 18.4? So 18.4 is definitely less than the 18.9 because again, it would be closer to 18 than it is to 19. All right, now let's try another one. So let's do the square root of 252. So 225 comes to mind, and that's going to be a 15. All right, and then 16 is if we did 256. So if we did the square root of this guy and the square root of this guy, this is between a 15 and a 16. Now the question is it 15 point something closer to 15, or is it going to be a 15 point closer to 16? All right, well, let's just compare. Since 252, see how 252 is really close to 256? So I know this square root answer is going to be really close to 16. So this value should be really close to a 16, meaning it's going to be something like a 15.8 or a 15.9. So this side is definitely going to be bigger than a 15.1. All right, now again, just checking because I'm taking the notes with a calculator here. But to estimate, if I did a 252 and did the square root, again, boom, 15.8, that's what I just said. So that's definitely bigger than the 15.1 that would be over here. Okay, it should be much closer to 16, so bigger than 15.1. All right, now for this one, the square root of 10, it's on this side, so square root of 10, it's really close to the square root of 9, and it's also in between the square root of 16. All right, so if the square root of 9 is a 3 and the square root of 16 is a 4, we know the square root of 10 is somewhere between 3 and 4. And now I want to compare to 3.5. Well, 10 is really close to 9. So the square root of 10 is going to be really close to 3. So it's going to be like a 3.1 or a 3.2 or something. It's going to be really close to 3. So that means it would be less than halfway through 3.5. And again, the calculator, just to check, if I've got the square root of 10, see, it's a 3.1. So that is certainly less than a 3.5. Now that we've taken notes on how to estimate where the square root would be on a number line, between which two straight up numbers it is, or which one's bigger or smaller, you're going to try now here. You're going to try just by putting some on the number line. You're going to tell me between which two numbers it is, and then just comparing with a greater than or a less than symbol. And there will be a Google form for this part, just so you know. But that concludes today's video. Thank you for watching.